We're really glad that all of you could make it. Hope you're enjoying Cloud Next 2019. Now, over the past few years, you've heard us talk a lot about how Google Cloud is built on top of our global network infrastructure. This year, we wanted to take the opportunity to dive deeper into this aspect of the global network design, talk about how it enables features in global virtual networks, or VPCs, and hopefully encourage you to think big and to think global when you're planning for your own application deployments. We have a 50-minute talk today. My name is Neha Pattan, and I'm a software engineer at Google. I'm going to be joined by Marshall Vale, who is a product manager on the Cloud DNS team, and by Ed Hammond, who is a senior enterprise architect on the Cardinal Health team, and he's going to be sharing with us the inside scoop on how Cardinal Health deploys VPCs. So this is basically what cloud consists of. Cloud is divided into regions, which further get subdivided into zones. Now, a region is a geographic location in a certain continent where the round trip time, or the RTT from one VM to another, is typically under 1 millisecond. A region is typically divided into 3 or 4 zones, and a zone is a geographic location within a region which has its own fully isolated and independent failure domain. And so no two machines that are in different zones or in different regions share the same fate when it comes to failure. So they're definitely in different data centers. In GCP at this time, we have 19 regions and 58 zones. So how does Google's network infrastructure power this? Now, Google's network infrastructure basically consists of 3 main types of networks. The first is the data center network. This is what connects all the machines in a data center together. The second is a software-based private WAN that we call B4 that connects all the data centers together. And the third is also an SDN-based public WAN for user-facing traffic entering our network. So a machine basically gets connected from the internet via the public WAN and gets connected to other machines in other data centers over the private WAN. So when you send a packet from your virtual machine running in cloud, let's say in North America, to a GCS bucket running in Asia, for example, then the packet doesn't leave the network backbone. It basically doesn't traverse over the internet, it traverses over Google's network. Now, one of the things that I would like to mention here is that in addition to the peering routers at the edge of our network, we also deploy network load balancers and layer 7 reverse proxies. The layer 7 reverse proxies basically help us in terminating the user's TCP or SSL connection at a location closest to the user. Now, this is really important because, as you know, establishing an HTTPS connection requires 2 network round trips between the client and the server. And so it's really important to reduce the RTT between the client and the server. And we do this by bringing the server closer to the client. And so we basically terminate the end user's TCP or SSL connection at a location that is closest to the end user. So this is basically what comprises the global Google network. With 134 network edge locations, presence in over 200 countries and territories, and content delivered through Google Cloud CDN, you get access to the same functionality that also powers all of Google's services, like search, maps, Gmail, YouTube. Each of these are used by over 1 billion users worldwide. This is a snapshot of our footprint. In GCP, as I mentioned before, we have 19 regions. We have also announced 2 new regions that will be turning up before the end of this year. So we are turning up regions in Japan and South Korea this year. Before the end of next year, we'll also be turning up 2 more regions in Salt Lake City in USA and in Jakarta in Indonesia. As I mentioned before, we have 134 POPs, or points of presence, and 96 CDN locations. Our data centers are connected to each other through hundreds of thousands of miles of fiber optic cable. We also have 13 subsea cable investments. We have 81 interconnect locations. So these are basically sites where you can physically peer with us directly in order to use either dedicated or partner interconnect. So why is all of this important to you? Why do you care that the network is actually global? Now, if you were to deploy your applications, you would do so by deploying the applications to multiple VMs in a single zone in order to protect yourself against single VM or single machine failures. In order to protect yourself against single zone failures, you can replicate your application across multiple zones in the region. So this basically gives you added redundancy and so increases the availability of your application. In order to further protect yourself against regional outages, so things like natural disasters or other such rare events, you can then replicate your application across multiple regions. And this is how you get a global deployment. Now, what is critical here is that with global deployments, you are assured that all the traffic stays on Google's network backbone and does not leave Google's network backbone. So you get access to all of your compute and storage resources globally and privately, which means that you don't need to assign public IPs to your VMs, and you don't need to set up expensive VPN or peering connections in order to stitch regional VPCs together. Now, another way of designing for robustness is to use load balancing. Due to the global nature of Google's network, we are able to offer global load balancing so that you get a global IP address assigned to your load balanced application. So a user in Taiwan sees the same global IP address for your application as a user in Texas, and they both get routed to the closest healthy backends. So the user in Texas may get routed to the closest healthy backend that may be running in Portland, Oregon. But if there are no healthy backends that are running in any region in North America, they may get routed to the next closest healthy backend, which may be across the Atlantic. But the important thing here is that the end user's TCP or SSL connection will get terminated close to the location of the user before getting encrypted and then routed over the Google network backbone to the data center in Europe. We use the same DDoS protection system in cloud as we do for the rest of Google, and so you benefit from the same perimeter security that the rest of Google services have. We are able to assign a single global IP address to our load balanced applications using stabilized Anycast. Now, Anycast, as many of you would know, is an addressing and routing methodology that allows you to route datagrams from a single sender to the receiver that is closest to the sender among a set of multiple receivers that are all programmed to serve traffic and to receive traffic on the same IP address. We use stabilized Anycast in order to preserve the TCP session despite BGP instability. So if an end user's ISP is recalculating the routes that they are announcing, then there may be a certain amount of instability in the TCP sessions that the end user experiences. As a result of this, the end user's request may get routed to a network load balancer in a location that is not closest to the end user. Now, when this happens, the network load balancer in that location figures out that the client IP is actually closer to a different location and then forwards that request to that location. So this is how we basically preserve TCP session stability despite BGP instability. So that's all about the physical network. How does this enable features in the global network, in the virtual network? So as you know, virtual networks or VPCs in Google Cloud are global in nature. So you can create your network once, you can associate network policies once in your network. So things like firewall rules and routing policies can be applied once to your network. And these policies will work seamlessly as you expand to multiple regions and you place your compute resources in new regions. If you're an enterprise network administrator, then you can use shared VPC in order to centrally create and manage your network while allowing full autonomy to your developers and allowing your organization to scale to hundreds or even thousands of developers or development teams. So let's take a look at an example. Now let's say in your organization you would like to create two types of applications. One is a web application that is internet facing, and the other is a billing application that is not facing the internet. With shared VPC, you can create a load balancer in your web app project. For reasons that we discussed earlier, you will want to create redundancy, and so you create compute resources in multiple regions. And then you can set these as backends of your load balancer. You can then create internal load balanced applications inside the billing project, and you can use your billing backends as billing VMs as backends to these internal load balancers. And thus, you can create multiple tiers of applications in your shared VPC. You can then associate firewall rules within the VPC in order to restrict traffic. Due to the global nature of our network, you also get access to Google managed API services privately, which means that you don't need to assign public IP addresses to your VMs in order to access API services like your cloud storage, machine learning, Bigtable, Spanner, and many others. This functionality of privately accessing Google managed API services is now extended to the on-prem, so that you're able to access Google managed API services privately from your on-prem network via VPN or interconnect. In order to secure your VPC, you can use network layer firewall rules. Network layer firewall rules are stateful and connection tracked. Now you can create, allow, or deny firewall rules either in the ingress or the egress direction by specifying source IP ranges or destination IP ranges. You can also use tags or service accounts in order to easily group resources that you're applying firewall rules on. Now, another really important feature is enable and disable firewall rules. This is something that we have launched in the past year. So if you're troubleshooting your network and you would like to find out the root cause of an issue by temporarily disabling a firewall rule and seeing what the effect it has on the network, then now you don't have to delete the firewall rule and recreate it. You can simply disable and then re-enable the firewall rule. Another really important feature that we have launched to GA over the past year is firewall logging. Firewall logging basically allows you to see reports of connection records that get created for every time a firewall rule gets applied on a connection. Firewall logs are not sampled, unlike VPC Flow Logs, but there is a limit on the number of connection records that get exported in a 5-second interval, and this limit depends on your machine size. Firewall logs get exported to the shared VPC host project so that the security administrator of your organization can view the firewall rules and verify that the firewall rules in the organization are administered and are getting applied correctly. You can export firewall logs to Stackdriver, Cloud PubSub, Cloud Storage, or BigQuery. Now, as I mentioned, firewall logs consist of connection records where a connection record gets created every time a firewall rule gets applied. So for VM to VM traffic, there would be a connection record that gets created for the egress rule on the sender VM and for the ingress rule that gets applied on the receiver VM. This is also true for VM to VM traffic in the VPC, even if the VMs belong to multiple service projects. And for traffic that is entering or leaving your VPC, either to go to a either to go to a peered VPC, to go to the internet, or to go to your on-prem through a VPN connection. Now, if you would like to apply security policies at the edge of our network, then you can do so by creating security policies using Cloud Armor. And what this allows you to do is to specify the rules that should get applied at the edge. So this is perimeter security that gets applied on your load balanced applications. So let's say you create a load balanced application. You can now associate security policies using Cloud Armor with the load balancer. And this assures that the traffic that is permitted to the load balanced application will conform with the rules that you've specified. So your VMs basically don't see traffic from the senders that you have blacklisted. You can specify Cloud Armor rules using IP blacklists or whitelists. This set of rules, this functionality is basically generally available now. You can also specify the rules using WAF rules or geo-specific rules, or you can use a flexible rules language in order to customize the rules that you would like to specify. So what does a typical deployment look like? Now, in a typical deployment, you would create an HTTP or HTTPS load balancer. This is the global load balanced application. And you would automatically get defense against DDoS attacks. This is because At the edge, we implement the DDoS protection, and so any traffic that is entering our network will get DDoS attacks defense for free. If you would like to apply custom rules for your load balanced application, then you can use Cloud Armor, and you can associate the Cloud Armor security policy with your load balancer. If you would like to allow access to your load balanced application only for users that have been granted this access using IAM policies, then you can use a product called Cloud IAP. That's short for Identity Aware Proxy. So what the Identity Aware Proxy does is that it checks whether the end user's credentials have, it will check these end user's credentials against IAM policy, and it will check whether the end user has been granted IAM access to this load balancing application. And if it has, then it will allow the traffic to come in. So traffic will basically enter your VPC. It will be received by the VMs only if it is allowed both by Cloud Armor as well as the Identity Aware Proxy. Within the VPC, you can use network layer firewall rules to specify the security on your VMs, and you can specify them so that you're allowing traffic only from the load balancer proxy, and you don't have to open your VMs or your ports on the VMs to the internet. Another really important aspect of design, of security design, is ensuring that you mitigate the risk of data exfiltration. You can do this now using VPC Service Controls so that you define a service perimeter or a security perimeter outside of which your data should not be accessible or it should not be allowed to be copied. With the functionality of allowing private access to Google services from your on-prem network via VPN or interconnects, the definition of your security perimeter can also be extended to your on-prem. So that brings us to the next question. How do you access on-prem? Now there are multiple ways of connecting your virtual network running in the cloud to your on-prem network. You can do so using VPN, and you can either configure VPN using static routes or you can use Cloud Router in order to dynamically exchange routes using BGP. Or you can use interconnect, in which case you're directly peering with us. And you can use either dedicated interconnect, where you control the peering, or you can use partner interconnect, where you are paying a partner for, where the partner is basically peering with us and you're paying them for the bandwidth that you use. You can create VPN connections or interconnect attachments in the shared VPC host project, and the virtual machines and all the service projects that are attached to the shared network will then get access to your on-prem via the VPN connection or the interconnect. We are really excited to announce now the option to create highly available VPN connections. With highly available VPN, you can create two interfaces on your VPN gateway, and you can connect the peer gateway on your on-prem to these two different interfaces. Each of these interfaces gets a different IP address, and this allows redundancy in your connection to your on-prem network. You can either use highly available VPN in active-active mode, in which case you are advertising the routes from your on-prem using the same med value or the same priority, and you would need to use the same base priority as well when advertising those routes to your VPC. And in this case, the route, both the tunnels will be used, and the traffic will be ECMP hashed over both the tunnels. Or you can use it in active-passive mode, where one of the tunnels is used while it is up, and when we figure out that the connectivity is down, then we fall back to the other tunnel. This basically increases the availability of your VPN connection to your on-prem by 90%. And so in a single region, you get 4 nines availability for connecting to your on-prem network. Now the next thing that we have launched to GA over the past year is Cloud NAT. Now Cloud NAT is a feature that a lot of our enterprise customers have been asking for, and they're really excited to use. Cloud NAT is basically a managed NAT solution that allows you to configure access to the internet on your virtual machines without having to give your virtual machines public IPs. We implement outbound NAT, we don't implement inbound NAT, and so this increases the security of your VPC by ensuring that connections cannot be initiated from a malicious user on the internet to your virtual machines running in the cloud. Cloud NAT basically scales seamlessly across VMs and across connections by handling both static as well as dynamic IP allocation. You can configure NAT as well in the shared VPC host project in the regions where you have virtual machines that need connectivity to the internet. So let's imagine that you have a package server that you would like to download packages from onto your virtual machines running in your VPC before you can bootstrap them. Now, after you configure the NAT gateways in your shared VPC host project, the VMs in all the service projects that are attached to the shared VPC will be able to access the packet server using the IPs that are managed by the NAT gateway. One thing that is really important to mention here is that NAT is a control plane component. It's not a proxy-based solution. And so you get the same bandwidth and performance for your internet connection as you would if you were to give public IPs to your VMs. So NAT basically scales really well. You need a single NAT gateway because it's not a proxy-based solution in order to manage the NAT IPs for thousands of VMs in that region in your VPC. Now, if you assign public IP addresses to your VMs primarily for getting connectivity to the internet, but you also had the added advantage of being able to SSH to your VMs using those public IPs, then you lose that capability when you remove public IPs and when you switch to Cloud NAT, because connections cannot be initiated from outside the VPC using Cloud NAT. With Cloud IAP, and Cloud IAP is something we discussed briefly in the context of global load balanced applications, Cloud IAP is now extended to have functionality for TCP forwarding. And what this allows you to do is to specify IAM policies on who has access to SSH to your VMs. And when a request comes in, the proxy will basically check whether the user has been granted IAM permission to SSH access to the VM. And then if that check passes, then the SSH connection will be wrapped inside HTTPS, and then using TCP forwarding will be sent to the remote instance running in your VPC. Now, coming to the next topic, how do you access managed services? Managed services can be accessed by using VPC peering. So if you want to get full mesh connectivity between two VPCs that are running in cloud, they may be in different organizations or the same organization, then you can use VPC peering. We're really excited to announce the general availability of private service access. Now, private service access is a managed solution that allows you to get a private connection to a managed service. And the other really cool thing that it does is it allows you as a service consumer to specify a global IP range and hand this off to the service provider so that all the subnetworks in the service provider's VPC get carved out of this global IP range. And so as a consumer, you're able to better plan for the IP ranges that are used for your managed services. One of the really important features that we have added as functionality to VPC peering is the ability to access peered VPCs from your on-prem network. And so you can, if you have a VPC and you're accessing a managed service through VPC peering, and you have a VPN connection from your on-prem to your VPC, then you're able to also access the managed services from the on-prem via VPN or interconnect to your VPC. The other feature that we have launched, which is now available in beta, is the ability to control custom route exchanges. So let's take a look at all of these in more detail. So let's say you have two networks. The one on the left is a consumer VPC, and the one on the right is a producer VPC. These two are in different organizations, and once you peer these two VPCs, you get full mesh connectivity between all the virtual machines in both these VPCs. And so you're able to access the managed service VMs from virtual machines in different regions in your consumer VPC, as well as in different service projects. So basically, you get full mesh connectivity. Now, let's imagine an example where the consumer VPC basically has added custom routes in their routing table. So on the consumer VPC's routing table, you can see the default local routes for the subnets that are created in the consumer VPC. You can see the peer route for the subnet that is created in the peer VPC. And you see two additional static routes. So one of them is a static route to the VPN tunnel. So that's basically a route going to the consumer's on-prem. And there's another route that is configured to next hop to a VM. So let's say you have an appliance that is running on the VM. On the peer side, you're able to see the default local route to the subnet on the peer VPC. And you're also able to see the peer routes to the subnets that are added in the consumer VPC. However, by default, you cannot see the custom routes that get added in the consumer VPC. And so the route to the VPN as well as the route to the VM appliance are not visible in the routing table of the producer VPC by default. With the ability to exchange custom routes over VPC peering, these routes will now be visible in the producer VPC. And so if you enable export on the consumer and you enable import of custom routes on the producer's routing table will be populated with the static routes that are defined on the consumer VPC. So here you can see the 10.4/16 which goes to the consumer's on-prem via VPN, as well as the static route 10.5/16 which goes to the VM appliance are now visible in the routing table of the producer VPC. You can disable this by either disabling export of custom routes or by disabling import of custom routes on the receiving VPC. Now both export of custom routes as well as import of custom routes are disabled by default. And so in order to exchange custom routes, you need to enable export on the sender VPC and enable import on the receiver VPC. Now the next topic I'll be talking about is that of VPC Flow Logs. Now VPC Flow Logs are basically a feature that we announced and launched last year. And we have enhanced this product in order to allow you to have more control over the flow log size that gets generated. The default aggregation interval for VPC Flow Logs is 5 seconds, but now you can configure this and change it to be anywhere between 5 seconds to up to 15 minutes. You can also configure the flow report sampling. By default, the sampling is 50%, and you can now configure it to be anywhere between 0 and 100%. So this basically allows you to control the flow log size that gets generated. We also add certain metadata to flow logs, and there is now an option to exclude this metadata. And with that, I would like to invite Marshall on stage to share with us a few recent announcements on Cloud DNS.
Thank you, Neha. So my name is Marshall Vail. I'm the product manager for Cloud DNS here at Google Cloud. And so one of the key elements of connecting your resources together in your VPC is, of course, DNS, or the domain name system. Today, I'm going to give you a summary of those types of capabilities that Cloud DNS provides for your VPC, along with a couple of exciting new announcements. Of course, it all starts with Cloud DNS private zones. Private zones allows internal DNS resolution to your private network. Now, it's important to keep your internal resolution to your private networks because that helps exclude external parties from discovering information about the resources, of course, on your private networks. Private zones can be attached to a single network or multiple networks in your VPC. Private zones also supports what's called split horizon, which allows you to do overlapping public and private zones. So, for example, you may have a portal that looks different for your employees than it looks different from your customers. Private zones also supports IAM policies, so you can delegate administration capabilities, edit, or view capabilities for your zones. Pleased to announce that private zones is now in general availability. Also very excited to announce here at Next the availability of Stackdriver logging and monitoring for your private zones. This allows query logs and counts about responses to be logged to Stackdriver. From there, you can, of course, store it long-term in Stackdriver, but you can also use Stackdriver's pub/sub capabilities to send that along to other storage locations such as BigQuery, but also on-prem for your own storage and analysis tools. The query logs that are recorded are very similar to bind logs that you're familiar with. It stores information such as QName or RData, but also specific GCP Cloud DNS things such as project ID or DNS policies. So for the metrics and the monitoring, that records information such as serve fails or NX domain counts. And this is all really important because it helps you debug your DNS situations in your VPC, but also it's important for security analysis for threats in your system. Pleased to announce that here at Next, it's now available in public beta. So I've been talking about Cloud DNS services within your VPC, but you also may need to connect your DNS services from your VPC to other locations, such as on-prem or even another VPC. So for connecting to on-prem, we have a capability called DNS forwarding. This allows bidirectional DNS resolution from your GCP resources to your on-prem resources. Now, DNS outbound forwarding allows your GCP resources to resolve host names using an on-prem authoritative server, such as Bind or Active Directory. DNS inbound forwarding does the opposite, allows your on-prem resources to use Cloud DNS as your authoritative server. You can learn a little bit more about DNS forwarding and, of course, your variety of hybrid connection options in the Net 204 session. DNS forwarding is currently in public beta. Also very excited to announce availability of DNS peering. This allows you to cross DNS resolution across multiple VPCs. Let's look at a couple scenarios. First is, say you're a SaaS provider and you want to connect with the VPC and your consumer. The consumer would be creating a special DNS peering zone that would connect to the network in the service providers in VPC. And they would have their own zone that the final resolution would happen from. Or you might want to combine this with DNS forwarding to create an architecture where you have multiple VPCs that can use an on-prem authoritative resolver. From there, you would make a single VPC that would be a hub VPC doing DNS forwarding, and you have multiple spoke VPCs that would use DNS peering to connect into the hub VPC. DNS peering even supports resolution for your .internal addresses. Here at Next, DNS peering is now available in public beta. So with that, you can see a summary of the Cloud DNS services for your private zones and the wide variety of flexibility that it supports in your VPC architectures. So with that, I'll pass it back to Neha to give you a summary of what you heard today.
Thanks. Thank you. Thanks, Marshall. So to summarize three main takeaways that we would like you to focus on from our presentation is that VPCs are global in nature. They are built on top of a global network backbone, and you're assured that the traffic basically never leaves the network backbone. You get access to all of your compute and storage resources globally and privately, so you don't have to assign public IPs to your virtual machines in order to access managed Google services like cloud storage. You're able to configure your global network once. You are able to associate network policies with this network, and you're also able to centrally create and manage the network in your organization while allowing your organization to scale to hundreds or even thousands of developers or development teams. Security comes first with Cloud VPC. You can apply network layer firewall rules for specifying security within your VPC. These firewall rules are stateful and connection tracked. You can specify Cloud Armor security policies in order to apply rules that get enforced at the edge of our network for your load balanced applications. And you can also use VPC Service Controls in order to mitigate the risk of data exfiltration. VPC features are basically integrated with Stackdriver logging. And now with VPC Flow Logs and Firewall Logging, it is really easy to monitor VPCs. With that, I would like to invite Ed on stage to share with us Cardinal Health's story on how they deploy and use VPCs. Thanks.
I should start by saying this is a really great session. I've actually watched it a couple times. So for those on video, you might want to go over it a couple times. In Cardinal Health, we're a Fortune 500 company, and we have used a lot of the features that you've heard today. We're a global enterprise, and so we have services running all over. Primarily, our first deployments in GCP have been within the United States, but we have plans and designs to fully go global, and we provision a lot of that in our networks. Our business objectives are in adopting cloud is to largely be quick to market, be able to adopt different technologies very quickly, and be very cost effective. Obviously, in all our businesses, we want to try and save money, and so we're always interested in trying to be the most effective with every dollar we spend. The other thing that we have to do is we have to make sure that we're protecting all our healthcare information. There's lots of regulations in various different countries about healthcare information, so protecting our customer information is very key to us. As far as having agility and being able to be flexible and speed to market, we want to try and move our shared services traditional structure more into a DevOps model where development teams can provision their own services, but we still need to make sure it's secure. So we need to provide techniques and capabilities where they can be very agile, very flexible, without having to say "Mother, may I," if you will, and but still keep all those guardrails in place so that they don't do something that would be compromising to our customer data or to the enterprise. And of course, I mentioned the cost effectiveness. Obviously, that's a key aspect. So what we chose to do early on was we created 2 host projects. So we have 2 host projects that basically do all the network things. So that what that does is for our application teams, they don't have to think about all those network pieces. All the interconnects and all that kind of stuff is hidden from them. And then we have hundreds of service projects that sit on top of that. And they use these 2 host projects. We have one for production, one for non-production. Each one of those have multiple different VPCs. And those service projects are then allocated or authorized to be used by various different development teams. Those development teams then are able to utilize the network. One thing that if you're in the network world and you've talked to a lot of developers for any length of time, you'll find that you start talking about routes and BGP and firewalls and their eyes glaze over and they don't want to hear about it. I don't know about you, but I've run into a lot of that. So we try and make it very, very easy for our consumers being the development staff that are actually helping the business. And in that regard, there's lots of need for training. There's lots of need for documentation, and that is a continual process. In our company, it's very large, and we have lots of people coming and going all the time, so we're constantly doing this education over and over again. Documentation, training, videos, in-house webcasts and that kind of thing that we do are very, very key to our strategy there. We also have to make sure we have all the governance controls in place, both proactive and reactive governance controls. That's really critical to success in a highly regulated industry such as we. So the value of the host projects, again, is I have a small number of network experts, a very small number of experts that know how all this networking thing works. So all the interconnects, the VPN tunnels, VPC peering, how all that gets put together, all that physics that's behind the scenes, we try and make it simple and easy to consume. We have a few centralized appliances that we use. I gave a presentation earlier this week about how we use some centralized appliances to do some of the more traditional security perimeter work that you might expect in a large enterprise that's been around for a long period of time, and we're moving to the cloud. We have a lot of technologies that we have to bring with us. We also have need at times to create a separate subnet. Say, for instance, there's a service project that they have a very specific need. So we can create a subnet just for them and allow just that service project access to that subnet. So therefore, nobody else knows about it, just this one service project. That's pretty powerful. We've used that a couple times. As far as firewall rule management, again, this is one of those governance controls. We use firewall logging extensively. That was a great feature that we looked forward to and have been using it since the day it was released or available to us. We've been using it for a while. But we use service accounts. So the goal here is that I have a VM instance, say, another VM instance, and it's in my own service project. We allow the target and the source to be the same, and we allow ingress and egress rules for those so they can talk to each other. So it's wide open any, so I have a collection, if you will. Within my service project, I can grant that. If I want to go between two service projects, then I go service account to service account. What that does is it gives us pretty good segmentation across the different projects and pretty tight controls in that regard. When we have a standard pattern, like a north-south pattern, for example, internet, an internal web server. An internal web server is a standard 80 and 443 allowed in from the RFC 19 address space. And so if that's the case, then we allow them to put on a network tag. This has been pre-approved by security. And you apply that network tag only to the VM instances where that applies. So not everybody gets it, but now as a DevOps team, I don't have to go to the network team to do a firewall rule. I just apply that tag, I get those firewall rules. In some cases, we have network tags that apply both at ingress, egress, and routing rules. For example, so our egress, we use that for to get out through some security appliances for some certain use cases. So we do it based on routing and firewall rules as well. And then we also have cloud functions that actually monitor some of these firewall rules so that we don't do anything really dangerous. This is the reactive. And so if somebody, for some reason, creates a firewall rule that was not supposed to be the case, we shut that down within seconds. I'm guilty of doing that. I created a firewall rule. It was 000. I was doing it in a very specific use case. The function caught me, closed it down. I re-enabled it a couple times, and I'm like, oh, I know what's wrong. I didn't add myself to the exclude list. So that was a good test. It actually worked, just what we wanted it to be. The value of the service projects, again, is for the DevOps teams. So a DevOps team can actually build all their resources. As you know, a project is abound for authorization as well as for costing. In our case, we have costing based on projects. So with that, we can delegate the accountability down to a DevOps team and let them move on their own. Again, we advertise only, I say advertise, it's grant the permission to only selected subnets to these projects. So rather than seeing all the VPCs that we built, rather than seeing all the subnets that we built, we only advertise selected subnets. So say, for instance, your project wants to run in Europe and only in Europe. I'm not going to show you any of the subnets that are in the United States. Same way in the United States or in Asia, whatever. So that's very, very capable, very, very powerful to us. So then the developers don't have to start thinking about all these network things. It's US Central 1 or US East 1. That's a pretty simple thing. Developers can deal with that. Okay. We also have an organizational policy that prohibits the creating of any instances with an external IP address. Obviously, the NAT capability was a powerful feature in that regard as well. Okay. So to sort of summarize, showing on this picture, we have multiple different VPCs. Each one of these, global network X, Y, and Z, we have different VPCs, and those are provisioned in the host project. Within any service project, I may expose only one or two subnets. And in this case, Service Project B and Service Project A are communicating to each other from different regions. They can be global, over the Google backbone, and that all works. And the firewall rules that you see on there, I have illustration of 3 of them. The first one is the internal web server. So that's a network tag-based rule. So if I put that on my server, I can receive 80 and 443 traffic in, my decision as a DevOps person. And then the middle one is the service count to service count. So if you're in that same service count, you have ingress egress to all your peers, and that's an any kind of rule. And then the last one is service project to service project. So we're using as much as we can service count to service count, and that gives us that point-to-point communication. Well, that concludes my portion of the presentation. I'll turn it back over to Neha.
So we might not have too much time for questions, but we'll be available outside this room for Q&A. So thanks so much, everyone, for coming, and see you again next year.